Welcome to EDU World Space.
So we have this problem where we're trying to find out a sample size. We want to find out how many people we need to sample with some given information. We know that they want to be 90% confident. We also know that the person's okay with the sample mean being within 10 of the population mean. So this is a margin of error. So we're looking at a margin of error of 10 minutes. And they've told us that the population standard deviation is 42. Now, when we do margin of error problems, margin of error, we have a formula for it, is the critical value times the standard deviation of the sample statistic. So we're looking at margin of error equals a critical value. Because we're in a mean, my critical value is normally always going to be a t star, and then the standard deviation of the sample statistic is the sample standard deviation divided by square root of n. But we know some things here, and we got a couple issues here. We know that t star, in order to find that, we need to know degrees of freedom. Well, in order to know degrees of freedom, you need to know sample size. And lo and behold, we're trying to find sample size here. So we can't use a t star. This is the one case that I tell my students that I know we're in a mean. I know we always do t stars and means, but we're going to do a z star in this case. So let me write in some information that I know here. My margin of error is 10. I'm going to change that t star to a z star now because we can't find a t star. My sample standard deviation, well, they gave me a population standard deviation, so whenever they give me that, I'm going to use it. So that's going to be a 42 divided by square root of n. So again, the n is what we're trying to find. But we still got that z star value. And how the heck do we find a z star? So I tell my kids, oh, well, z star means we're sort of in a normal distribution here. And we're at a 90%, so that means that area there is 90%. So that means I got 10% left over. Well, I got two tails, so that's a 5%, and that's a 5%. And I asked my kids, what is that value right there? Well, in order to find that value, we go to a z distribution. And that value is 95% of the data. So I'm going to look in the middle of all those numbers and try to find a 0.95. And for 0.95, I come up with a 1.645. So my z star is going to be 1.645. Now, if you know how to do this on your calculator, you can do an inverse norm and get the exact same value that way. So let me fill in some more information here. I know I got 10 now as my margin of error. And actually, let me back that up a little bit. I need to be bigger than that. So 10 is greater than. My z distribution, or my z star value is 1.645. We're going to multiply that by 42 divided by square root of n. Figuring this out, I always have my kids get that fraction by itself, so we're going to divide everything by 1.645. If I divide everything by 1.645, on this left side I get a 6.08. Has to be bigger than 42 divided by square root of n. And I tell my kids, this is the hardest algebra we're going to do in statistics class the entire year. I got to divide by square root of n. So I'm going to multiply both sides by square root of n. And I'm going to do one more thing at the same time. I'm going to divide by 6.08. So if I take that 6.08 and take it into 42, let's see here, I got square root of n, has to be bigger than 42 divided by 6.08, gives me a 6.909 about. It's the square root of n, so to get rid of that, we're going to square both sides, and I get n has to be bigger than 47.7. Well, we can't interview 47.7 people, and I need my margin of error to be bigger than that number, so n is going to be 48 people. So we want to sample 48 people in order to have all that information hold true for what the person wants.